Thank you for the reminder. Welcome one, welcome all. How are you guys today? I'm glad to hear it. I hope you guys are doing well. I hope this does nothing to change that. It is Wednesday, our second saddest day of the week. I am almost entirely done grading your exams, so I will have them back to you tomorrow. Let's see what else. That's it. That's all the news that's fit to print. So then to that end, last time we had just started talking about refraction, is that true? We finished reflection, we were just starting. That's where I left myself a little dot, which is how I tell myself where I stopped. I'm assuming that that's not a lie, but okay, so then that's where we'll pick up if it looks like I'm telling you stuff you've already seen, or it looks like there's a gap where I am relying on information I haven't given you yet. Tell me. Questions, comments, concerns about where we are, where we've been, where we're heading? Then, oh goodness. I do recommend looking at those problem session videos that I post on Tuesdays. So I did some examples of solving for image locations yesterday using single devices and multiple devices. So I think that might benefit you, but
where exactly do you post those? So I've been trying to find them and I can't seem to find them.
oh, heartbreak of heartbreaks.
It's in the home page.
Can you find these videos that I'm making right now?
No.
Okay.
It's in the home.
So go to contracosta.instructure.com, enter your single sign-on. When you do so, you should see a list, a Canvas shells for all of the courses you are currently taking. This one is Physics 231, 6247. Does that sound right? There's only one section, so if you see one with Physics 231, that's this one. Then you will see Welcome to Physics 231, some jazz like that. You'll see a picture of, I think the one I used this semester is, it's like an eye. It's the Eye of God. It's a Hubble telescope picture. And then some stuff about who your teacher is.
You draw the camera.
There's some stuff over here, but then there's week. If you click on, well, I guess we're in week 8, so if you click on any of these links, there's videos there. In fact, some of these still have like links to old videos from prior semesters. But if you go to the one I'm talking about right now is the Tuesday from week 8. That was the video set that I posted yesterday. I assume that if you're watching this, you already know how to get there. But if not, there you go. All right. So we have 2 different media, and 1 and 2. I didn't already draw this one for you, right? Okay, good. I'm getting forgetful. So if I really have the sense of deja vu that I've already done this for you, but
Yeah,
You
you
did something similar.
you did it yesterday.
so that would be roughly the center of curvature for the space. And so if I wanted to draw the normal to where this ray is striking, how would I do so? Connect the dots. Yay? Is this you guys just messing with the old person? Like, we really have done this and you're just letting me suffer through this? So, where's the instant angle with respect to the normal? It's this guy, right?
No.
Yeah? And so then, oh goodness. That seems unnecessary, but, yay? And so where's the refracted angle with respect to the normal in this? So if this is instant, the refracted is that guy? Does that work? Oh, then we could do that many, many, many times, and all of these rays should find their way to this point, yeah? And so if this is our object, our image would be back here. So far, so good? Okay. Let's try this with a little bit more attention to detail. I'm probably going to regret this, but you squint, maybe punch yourself in the eye. That's sort of circular. Notice none of you tried that, but okay. So best as I can get to splitting that. Then let's give ourselves an object. Does that seem sort of like the center? kind of? Alright, then we do kind of the same thing. It's what we did there, but I'm going to try and be a little more careful. Now the center's here. So much for being careful. Yay. Then all right. There's our theta 1. There's our theta 2. We have n1 and n2. And we also want n1 less than n2 in the drawing of right? Mm-hmm. Okay, so that's to be our object distance, our image distance. Should then be that. I am going to call this distance d. I'm also going to name this angle beta and this angle alpha and this angle gamma. Again, just as a reminder, may not look like it, but that's our center of curvature. That's our object, and our image would be here. This is good. Then, what does Snell's law give us?
1 sin theta 1 equals n2 sin theta 2.
True story. Okay. Let's assume that we examine a special case of theta 1 and theta 2 both much less than 1 radian. What can I say in that case?
Same data, it's just data.
Would it be y over l?
How about n1 theta 1 is n2 theta 2?
Is this squiggly sign after much?
Oh, radian, RAD. I let this be my equation 1. So we also have our theta 1 in terms of alpha and beta.
Theta 1 equals alpha plus beta.
Yep. Spoken like a math tutor. The exterior angle of this triangle, the two opposite interiors. Yeah? We could do the same thing with beta, theta 2, and gamma. Yeah?
Yeah, beta equals theta 2 plus gamma.
Call that my equation 3. I don't know if I used, oh, I did use all these. I combined equations 1, 2, and 3 to eliminate theta 1 and theta 2. And wound up with n1 alpha plus n2 gamma is equal to n2 minus n1 beta. Now I'm just goofing around, but I named that one 4. And so next, I went for, so we're already in a special case here. Now we're going to further restrict this. We're going to say, although honestly, theta 1 and theta 2 being much, much less than 1, what does that say about kind of D? D has to be pretty small in order for that to be true, right? Does that make sense? But if that's true, if I make, in order to make theta 1 and theta 2 small, that makes D small, what does that do to alpha, beta, and gamma?
Even smaller?
They have to be even smaller, right? So if I could make the argument that theta 1 and theta 2 were much, much less than 1 radian, I can certainly do that for alpha, beta, and gamma. So So what does that make the base of this right triangle? This first one.
Base.
Makes it basically P, right? And then for gamma, this right triangle,
Q.
it makes it practically Q, right? And for the beta triangle,
Base is R minus.
it makes it R, right? Because the center should be R away from the,
Professor, what's the law that allows to say that beta is, the theta 1 is gamma plus beta?
oh, we're making the statement that we've got this triangle,
Correct.
right? And so note that what is theta 1 plus whatever this angle is?
180 degrees.
180 degrees. But what is the total angle inside a triangle?
180.
180 degrees. So theta 1 plus this is 180 degrees. But note that alpha plus beta plus whatever this is also 180 degrees. So that means that theta 1 has to be these.
Oh, okay, I see.
Yeah?
Thanks.
So far so good?
Yeah.
Good question. I
Was
don't know about you,
trying to
but for me,
remember my
it's been a
trend
minute
pattern,
since
But I
I've
just can't
had.
figure it out, yeah, thanks.
If beta and the one next to it are really small, can't we say that Q and R are practically equal?
Not necessarily. That'll depend on N1 and N2, right?
Yes.
So then we have these three triangles. The bases of them represent three of the important parts of this curved, spherically curved boundary between one medium and a second medium. So we've got P, Q, and its radius R. And so and also tan theta, roughly theta, again for small angles. And so we can say that tangent of, I think I started with alpha, I did. It's roughly alpha, but what is tan alpha in this triangle equal to?
D divided by P.
True story. Yay? Tan of beta, again also roughly beta, but what is that one equal to?
D divided by R.
And then tangent of gamma, we waited oh so patiently, it's roughly gamma.
D divided by 2.
D over Q. Yay?
Yeah.
So then, if we take that, and again, I was clearly feeling whimsical. I called these equations 5, 6, and 7 in my notes. If I take 5, 6, and 7 and plug them into 4, we get that N1 times alpha was D over P plus N2 times gamma was D over Q is equal to N2 minus N1 times D over R, is that the,
Yeah, that's what is.
yay? So then,
Get rid of D.
so now we can get rid of, and because it makes me happier to draw like this, we get that N1 over P plus N2 over Q is N2 minus N1 over R. Yay?
Yes.
If you watched yesterday's videos, I used this equation. Now I feel less guilty because now I've also done it in lecture. I feel like this deserves a box.
We can use this. It's environment.
Hooray? And they all live happily ever after, at least for now?
So this will work if the index for refraction or whatever the circle.
Yeah, this is meant to
Yeah.
be, like, have you ever seen a pool cue? You guys probably lead better
Yeah.
lives than I do.
I'm familiar with.
The top of a pool cue is kind of like rounded over.
Yeah.
So imagine that it was made of glass. Then that's what I want you to think of this surface as. One example could be there's air out here, and then there is that rounded glass surface here.
And the object is outside. Would it be true if we switch things around, object inside?
So the example I did yesterday has, I don't want to spoil this.
In the
Like
fish,
ruin your
the fish
streaming videos, but
Streaming.
but in the example I did yesterday, there is fishbowl, n equals 1.33, n equals 1 out here. I asked you to think that the glass is thin enough that we don't have to worry about refractions at the glass, that you really can just think of this as water butted up against air. And so in this case,
The fish is inside the.
so the object is in this medium, right? And so that would be N1 for us. And N2 would be,
So that equation still applies.
yep.
Okay.
Yeah, it's just the definition of whether R is positive or negative. And I'll get to that in a moment.
So does the refraction change if the glass is solid instead of or hollow?
Did you guys? My father always told me, don't ask a question you don't want to know the answer to. And I'm about to show that I clearly did not learn from that. Because I'm gonna ask a question and it's gonna make me feel really old. Because this TV show came out well after I was an adult, like middle-aged adult. But did any of you ever see the TV show Lost?
I believe I was,
When you were a little kid, maybe?
I was born in 2000, so I might have just been.
When was that, Professor? Late 80s?
So, no, it was, I want to say it was early 2000s, maybe 90s.
Because I heard of it.
Yeah, I heard of it. So, okay, well, this is gonna mean nothing to you, because, but I'll ruin it for you. If you want to stream it, I'm sure, you
It's
know,
like, I don't know how many seasons that is.
it's like 7 or 8 seasons.
Yeah, you just go.
So, I gotta tell you, like, everyone was mad at the end. I was mad after the second
Was it that
season,
bad?
so. No, it just, the ending was kind of like, really? So,
Was it?
they're on a plane, next thing you know, they're on an island,
Oh, I know this.
Yeah, no,
so they don't know where they are. First, that's annoying to me because they don't even know northern or southern hemisphere. You can tell, because if you can see Polaris, you're in the northern hemisphere. If you can see the Southern Cross, or if you can't see Polaris, you're in the southern hemisphere, but, okay, fine. Don't get me started.
So who
But-
is lost? If the baby is lost.
All the people on the plane, maybe, who knows? You'll find out in the last episode, and you'll wish you hadn't spent 7 years watching that show.
Oh, it looks like an adventure instead of lost.
Yeah, there's all sorts of crazy creatures on this island. It gets absurdist, but that's, 2 seasons in, I was like, okay, fine. Just tell me when it's going to end so I can see what the mystery was. But if you're ever stranded on a desert island and you need to like fish to feed yourself, apologies if you're vegan. I'm sure there's coconuts.
It's not enough.
But-
And coconut milk.
Who knows? It's too much work for me. Have you ever tried to open a coconut? But
I miss my coconut.
if there is you're going to be eating Nemo, by the way. That's how you're going to stay alive. Better?
Sure.
Here, wait. Let's give him a hopeful look.
It's minimal.
Yes.
There we go.
Yes.
So there's the spear. So do you aim at the thing you see?
No. Aim a little in front of it.
Yeah. So the actual thing is going to be up here. So you need to assume that it's actually under where you think. Watch this video, well, or don't. You can do this problem because it's right there. I think the radius was 15 centimeters. This distance was 10 centimeters. The image is going to be a little in front of that. I think that we got 9. I can't remember, but something like that. So there you go. If you're ever stuck on a deserted island, don't say I didn't do anything for you. Now you know, don't aim at the thing you see, because that's not really where the fish is. We'll do that problem for a flat water surface. But let's do our sign conventions. So the object position P is positive if the real object is in front of the surface, or for a real object in front of the surface. And it'll be negative for a virtual object behind the surface. You were born in 2000. I was working at Los Alamos in 2000. I'm old.
I'm 18 years old in 2000. You are not. Maybe we're the same age.
Sadly, you are young. Not sadly. Enjoy it. You are young too. Sad that I am old. Although it's not. May you all be lucky enough to live to be old and complain that you're not young anymore. Positive for upright, negative for inverted. So, coming back to this picture again, I guess I shouldn't point at stuff that's off screen. Coming back to this picture, what's the object again?
Nemo.
Poor Nemo, right?
The fish.
Actually, this isn't Nemo. I erased Nemo because we ate him.
Dinner.
But
Dinner.
this is the fish that survived. So
No.
so is our radius of curvature here going to be positive or negative? So is the center of curvature behind the surface or in front of the surface? So where is the center of curvature of this?
Behind.
On your left hand.
It's back here, right?
Yeah.
So is that behind the surface or in front of the surface?
Behind
Behind.
the surface.
It's in front of the surface, right?
What?
Here's the surface.
It's like convex.
So where is the center of curvature? It's right here. So here's our surface, here's our object.
The fish is inside a bowl, right?
Yes.
Oh, okay.
The water's confusing everyone.
Doesn't it depend on your perspective?
Well, what's the object? The fish, right? And so the light is leaving the fish going towards the surface. I agree, if the eye is the object, right, then we're in a different discussion, but yay.
Yeah.
Because the entire bowl is a giant surface. So
Okay.
inside.
We'll put some math to our questions that if you ever do get stuck on that deserted island. Not that I'm wishing that on any of you. But. So for a flat refracting surface, what's an example of a flat refracting surface?
Flat. Mirror?
That's a reflecting surface.
Flat water.
Water?
Flat water, pane of glass, a block of glass,
A pool.
a pool, right? So in that case, what is the radius of curvature approach?
0. Maybe it's a copy.
How about 1 over that?
1 over. Infinity?
Yeah. Right, so this has a fairly short radius of curvature. Wow, that's not even a circle, but bigger radius of curvature, right? Really big radius of curvature, I don't know, somewhere like,
Oh, okay.
right? But if I want, like what happens, it starts to look more and more flat
Oh, okay.
as I,
Yeah, got it. Like if the entire surface is the Earth, so it
Yeah.
Flat. Okay.
Well, the Earth is just flat in general.
No, Earth is not.
I-
I'm crazy.
I normally use, and some of you have heard me say this, the first time that ever made sense to me was when I visited Oklahoma, because it was just like fields for as far as I could see, and it kind of looked flat. Like,
Columbus think the Earth is flat, so I go
he's messing
try
with
to
you.
find China, and I go to America because they misunderstand of the shape of Earth.
So, it's not that Earth is flat, it's that I'm short, right? So the problem with walking around Oklahoma is that I wasn't tall enough to see the curvature. That was the point of the issue. I have to find another state to pick on though, because I have.
Why don't we just
Let's
pick on
do-
Florida? Or is that too easy?
I'm being recorded, so I'm not picking on any state. Every state is wonderful. I love them all.
Ohio's no wonderful.
I love them all. They're all wonderful places.
What about New York?
I actually do like New York.
What about New Jersey?
I like Princeton. So, where did this go? I shouldn't have done it this way. So, we have that, hopefully this is visible, sort of. We have, for a flat surface, r approaching infinity, and so what can I say?
Infinity, so it's equals 0.
So, n1 over p plus n2 over q is equal to,
0.
hooray?
Yes.
And so we can say that n1 over p equals minus n2 over q, or that q equals minus n2 over n1 times p. Yay? So, kind of a classic example of our fish problem. Still can't draw horizontal line. We are going to let
Nemo's back.
this is Nemo's
Cousin.
brother. He's come to bat for Nemo.
It's his cousin Bob.
This is the last in the line of Nemos. So he is some depth d below the surface. We want to know what is the apparent depth if you are the good folks at Disney aren't at all litigious, right? We want to know the apparent depth. So can you help me out with this? What do we do? I want to know Q.
Q equals negative n2 divided by n1 p. What's p1?
So
P is
Q
the
So what's I?
Oh, p1 is
P is the distance of the object. What is
just
P?
the negative n2
What's-
divided by n1.
What are our two n values?
To
1 and 1.3.
One is 1,
Okay,
one
so-
is 1.33.
So which one is n1 and which one is n2?
N1 is the 1.
And one is 1.33.
Really?
Why?
The light starts inside the water.
Correct.
Oh. Why is it light start from inside? Isn't light should be from outside?
No, the light is reflecting off the fish.
Wait, it's in the nighttime or evening?
Well, so I don't think Nemo is phosphorescent, and so there's some kind of light, ambient, filtering through the water, strikes the fish, and is reflecting off the water, reflecting off the fish, back out of the water to my eye, to your eye. I'm not an E8 for Nemo. Or Nemo's brother, cousin, what do we decide? I don't know. Tastes the same either way, right? So what do we get here? This is about 4/3, so 1 over 4/3 is about 3/4, give or take.